In this video, we'll be working on number 11 on the Chapter 5 test review. We're going to have a bunch of different triangles, and we have to determine whether we can prove that each pair of triangles is congruent by using side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse leg. If it is not possible to prove that the triangles are congruent, write not possible. So let's look at part A. The two triangles in part A, we're trying to decide if one of our triangle congruence theorems apply. I notice I have one pair of congruent sides, two pairs of congruent sides, and one pair of congruent angles. So remember, to try to determine which theorem you're using, you only need to look at one of the triangles. So when I'm looking at this triangle, I have two sides and an angle. Now notice this angle is in between the two sides. If I connect the two sides, they form this angle. This is the angle that is in between the two sides. This happens to be the angle that is congruent in the triangles. So we have a side angle side congruence theorem. So yes, the two triangles are congruent by side angle side. In part B, our two triangles, we can see that they have three pairs of congruent angles, and that is all we can determine from the picture. There is no such congruence theorem as angle, angle, angle. Remember, no batteries, no AAA batteries. So this is not possible. In part C, I first noticed that we are working with right triangles. So my first go-to is to check to see if it's hypotenuse leg. To do that, I'm going to look to see first, are the hypotenuses of the right triangles congruent? Look at the side opposite the right angle. We do have a hypotenuse that is congruent. Is one of their legs congruent? So look at the other sides of the triangle. Here's a leg. It is congruent to a leg in the other triangle. So this is hypotenuse leg. Part D, I can see that I've got one pair of congruent sides and two pairs of congruent angles. So I've got a pair of congruent angles here and here. So to figure out which theorem this is, remember, just look at one of the triangles. I have two angles and one side. The question is this going to be angle side angle or angle angle side? So to figure that out, look at your two angles. Look at the side that is in between the two angles. That would be this side here. This side is not the side that is congruent. The side that is congruent is outside the two congruent angles. So what this means is these two triangles are congruent by angle angle side. In part E, our two triangles here have three pairs of congruent sides. So they are congruent by the side, side, side theorem. In part F, right away I can see I have two pairs of congruent sides. Now, if this was the only information I could find, I would not be able to tell if the triangles are congruent. However, hopefully you notice that these two triangles share a pair of vertical angles. This angle here and this angle here make a pair of vertical angles. So we know that these two angles are congruent. We can go ahead and add those arcs in the picture. Now I can see if one of my congruence theorem applies. I'm going to look at one of my triangles. I have two sides and one angle. Is the angle in between the two sides? Yes. So these two triangles are congruent by side angle side. Part G, At first, it might look like we don't have enough information to determine if these two triangles are congruent. I've got an angle and a side. Some of you might have noticed, though, that these two triangles share side BD, meaning by the reflexive property, BD is congruent to itself. So I'm going to go ahead and add tick marks in here, but now I've got to check, does one of my congruence theorem apply? I have two sides and an angle. In order to be side angle side, though, the angle has to be in between the two sides. So if I look at where those sides connect, my angle that would have to be congruent would be right here. That is not the angle that is congruent. So right now we're looking at a side-side angle. This is not a congruence theorem. Remember, no donkeys. So this example is one where it is not possible to determine if the two triangles are congruent. Part H got messed up a little bit. These tick marks were supposed to be here and here. Looking at my two triangles, I see they have two pairs of congruent angles and one pair of congruent sides. I'm going to go ahead and look at one of the triangles to figure out which theorem might be working in this problem. And I've got an angle and an angle, and notice how the side that is congruent is in between. This is an example of angle side angle. Part I have two pairs of congruent angles. Hopefully you noticed we could go ahead and add in a congruent side because they share side RT. So by the reflexive property, that is a side that is congruent to itself. So looking at the triangle, I've got an angle, and a side. The side, notice, is not in between the two angles. Therefore, this is an example of angle, side. In part J, this looked like this was one that got misprinted a little bit. I'm going to ignore this little marking here. So I have two right triangles. I know that one of their sides, which happens to be the hypotenuse, is congruent. However, that's all I know. I don't know if there's any other angles that are congruent. I don't see any vertical angles. I don't know if there's any other sides that are congruent. They do not touch and share a side. So this is one where there's just not enough information. This is not possible. In K, notice that we have right triangles. This one is a right triangle, which means this angle must be a right angle, and this is a right triangle. One of their sides, one of their legs is congruent. I don't know anything about these sides. I don't know if their hypotenuses are congruent. There are no tick marks there. However, I can add a tick mark on this side because they both share that side. So by the reflexive property, this side is congruent to itself. So looking at my picture, you might think maybe it's hypotenuse leg. But remember, we said we do not know if their hypotenuses are congruent. So you cannot use hypotenuse leg. Let's look and see if we can use anything else. I have a side. Their angles here are congruent. And I have another side. So because this angle is in between the two sides, this is an example of side angle side. And the very last one, part L. I have one pair of congruent angles. I know this is kind of light. These are arrows, not tick marks. So be careful. This is not saying that line segment TX is congruent to line segment SY. What it's saying is that they are parallel. Remember, parallel lines, we can use those to help us find pairs of alternate interior angles. So we're going to go ahead and try to find a pair of alternate interior angles in this picture. Here's my parallel lines. Here's my transversal. I can see that there's an angle formed here from this parallel line in the transversal. Its alternate interior angle would be down here in this triangle. So far, these two triangles have two pairs of congruent angles. Notice they also share a side. I can go ahead and set that side congruent to itself. So look at one of the triangles. I have an angle, and a side. This side is not in between the angles. It is outside the two angles. So this is an example of angle, angle, side.